What this is going to go over is our technology architecture for our platform. At a high level, I'm going to start with, this is essentially a physical architecture, what they used to call physical, because it's all software now, but you can think of it as physical nodes all in the cloud. And then this diagram is actually bigger. This is like one corner of it, and I'm going to kind of scroll around and zoom in and out as we go through it. I think there's a presentation product that does this, but I'm going to do it fully manually. So I'm going to dive right in. So on the far left there, you basically see our entry point, our domain for our products. App.flockfreight.com is how you get there with the web browser. API.flockfreight is also available, although we don't really, we have like a beta public API, but it's not very extensive yet. But in theory, that's where, if people wanted to use our services with an API client, that's where they would come in. And then as you go to the right, we get into our platform. So you can think of a web browser accessing our platform, and everything's in Google Cloud Platform within a service they call Google Kubernetes Engine. And I think it's Kubernetes, maybe it's Kubernetes. I don't know, I've heard people say it differently. If anybody has an opinion there, shout out. I say Kubernetes. And that is essentially an orchestration system that can spin up what we call spin up nodes, kind of virtual servers and other services, all from configuration files, which now have a lot of tooling around those to make them really easy to manage, and have a replica for a staging environment, for example, or for a developer environment. And so within Kubernetes, the first thing is the ingress, which is basically load balancing. So you've got you define all your rules for ingress and how things get routed, and they have built-in load balancing. And then you get right into the core of our services, which are two main services with very short names. One's called app and one's called API, right? And then with the diagram to the right of that, where it says deploy, that's kind of like the service app actually gets deployed. And the numbers, by the way, are reversed. There's 3 replicas of app and 6 of API. That's a typo, and that just means essentially you can think of a bunch of virtual servers running the same thing, and that's for high availability as well as for load balancing or load sort of horizontal scalability. The app node is the front end. So that's essentially serving up just a web, it's essentially a web server, and it doesn't do very much other than serve the request and let the client download the app, because our front end is a single page application built in React. So I do believe we're still running Node.js in there, but we don't really need to. It's like static basically. But and we'll see in a minute how authentication, what we're using there. But for legacy reasons, there is a Node.js server in there. But that could eventually become just content distribution network, right? Which Google also has built in. So then, and then below it, the API service, that you can think of as, that's where all the business logic is. So we have an internal API layer, a RESTful API layer that is not for public consumption, but is used by our single page app. So essentially a client server kind of concept there, and then everything behind it is business logic that runs all of the functionality that our users, when they click on things in the web browser, when they make API calls externally, if they were to do that, would be served up by that API service, or one of the replicas of it. So that's kind of where everything starts. And actually, that's really the bulk of the code. Like a lot of our code gets compiled and run here. So So it's just one little box here, but it's quite a bit of our code. So if I go to the right a little bit, then we'll see a little bit more of what's going on. So we also have some other things running. So we've got scheduled workloads. These are background jobs that run periodically. So Kubernetes has a built-in resource for that, essentially crons running that kick things off. So you can configure these, and then they'll run some service or call some API. And then below it, we also have some background processing. So I'll scroll down a little bit. And so these are a lot of other services that run in the background that can be either triggered by a cron job, right? Or by a sort of asynchronous requests that come from our API, right? So something, for example, can occur that will trigger something to run in the background. And this is this box also houses a lot of our code. In fact, a lot of our optimization code, a lot of the secret sauce is running in the background here. And then the results of that stuff are then served up in user interfaces and functionality that is implemented here. And so these are all running as Kubernetes nodes, and they have multiple replicas. And then down below here, you can see a couple of the services we also use in Google Cloud Platform. This queuing service, which they call PubSub, which manages all of that background processing to kick off an event that some other service will listen to, and it can handle high scale for that. And then the memory storage service is a memory cache, and it's built on Redis, which probably most people are familiar with. So you can see so I can zoom out a little bit. So so you can see some of the connections. So the API service may put some things into the memory store, for example, or may kick off some events into the queue, which eventually get processed by the background system, which can then either put something back into the queue or can write directly to the persistence layer. So that's the next thing here. So scrolling to the right from the services, so if we zoom in again, so we've got these system services, the most important one being the cloud Sql Proxy. So that's essentially the entryway to the persistence layer, which is a relational database. It's just MySQL, but again, running in Google Cloud. So it's all managed. And there's a proxy that any of these services can use to access our database and write information to be stored persistently. And then, of course, all the logs that are written by different applications. This bird icon is a product called FluentD, which essentially collects logs from a bunch of different services and then pushes them into the back end, which I'll explain in a second. And then StatsD is another, basically logging, just taking statistics from all of the different virtual machines that are running these things, how much memory is being used, et cetera, which can also be analyzed. So then if we go to the right, then we get into the data tier, what's storing all this stuff. And again, the main persistence layer is just Cloud SQL, which is really simple. So it's all managed. There's a primary, and then there's replicas. There's a master slave kind of setup, and the proxy just lets you write to that stuff. And then Google Cloud Storage, that's basically just like Amazon S3. It's just buckets, and so all of our logs get forwarded into those. And then there's a Google product called Stackdriver that lets you visually inspect all the logs and search them. It's okay, there's third-party products like Loggly and Splunk that are supercharged versions of that. We're still just using Stackdriver. And then above here is our data warehouse tier. So all of the data that's in our relational database gets replicated. That's this extract and load. So this icon is a product called Fivetran. So we use a third-party SaaS product or PaaS product that can automatically connect to MySQL and replicate data into a data warehouse, which we're now using Snowflake for the data warehouse. And then we use this other tool called dbt to do additional transformations for performance or usability reasons for analytics. And then Fivetran also pulls this, not shown in the diagram, but Fivetran connects out to all the other third-party SaaS tools that might be used. In fact, I think Flash wrote one of the connectors to pull from one of the sources that Fivetran didn't have out of the box. And we had another consulting company write a couple connectors as well. And then they have a bunch out of the box. So for example, if you're running Salesforce or you're running HubSpot and you're running other things, you can collect all that stuff and get it into your data warehouse. So that's what Fivetran does. And then from there, we have these analytics tools that are, other SaaS products. One is called Mode Analytics, and the other is called Sigma Computing, which I highly recommend if you're looking for a BI or analytics solution. And those are just products that sit right on top of a data warehouse and let you do visualizations and dashboards and things like that. So that's kind of our data stack here. Then if I go up a little bit, we'll see some of the third-party vendors that are kind of key to our platform. So Splunk over here is only shown. It's actually a product called VictorOps, which they purchased. So that's it's like PagerDuty. It's a system that will automatically call engineers in the middle of the night if somebody logs an emergency issue. And so that's all that is. And then Okta is an authentication and authorization provider, cloud-based. So they're tied into that gets connected right back into the app. So with regard to logins and things like that, forgot password, all the passwords are stored in Okta. They have a lot more features. They can handle SSO and OAuth and a bunch of other cool things out of the box with APIs. So that's what we use them for, but we're just scratching the surface there. And then there's some third-party tools for observability, application performance monitoring, et cetera. And we use a product called Datadog, which also I highly recommend. Excellent product to pull essentially all the stats stuff, all of it, and you can do custom metrics. So our app can actually push metrics to Datadog, and then you can create service level objectives and track how everything's doing. I can demo it. It's very cool. So you have really good visibility on what's going on and what's not going right, and then you can use it as a debugging tool. This other product is called Sentry. It's another really cool. There's so many products now for developers that are amazing, compared to what I remember having to do. So Sentry plugs in and pulls all the logs and captures all the exceptions and errors that are happening and creates a whole workflow and user interface around it, so you can keep track of all the things that are, you're never going to catch everything in QA, and then what happens in production is often really esoteric compared to what you're seeing in test, and so it lets you keep track of all the errors and manage them. So that's kind of the top half. And if we go a little bit down below, so that's really the platform at a high level, right? And then if we go a little bit below here, we go into a couple of details with regard to just what languages are used, and then the continuous integration and continuous delivery. So Python, TypeScript, and Java. So down in this area, in these workers, this is where a lot of the applied math and data science and optimization algorithms, a lot of that stuff's written in Python. Here in the API, this is all Java. And then at the app level, that's all React and JavaScript, but more and more moving to TypeScript. And then down here for CI/CD, so this is our mono repo inside of GitHub. So everything's in GitHub in one giant repository. And then we use a product called Sql CI to run all of the builds. Again, excellent product that generates Docker images, and then the GitOps box basically is the stuff I mentioned, how Kubernetes is very declarative. So Helm is this system that lets you manage all those configurations, and Terraform is a layer on top of the raw kind of Kubernetes. So it basically lets you define all, essentially like, here's all my servers, here's all my replicas, here's how I want everything laid out. It's all defined in these tools, and they actually get built, and you can deploy like literally your platform, right? And so all of that is used. And then this is Jenkins. So we still have Jenkins running ourselves for some of the CD, but that's going to be eliminated in favor of you can do everything in Sql CI. We just haven't moved everything over to it. So that's the high level. That's where I was going to pause. And then, where it gets interesting is drilling down to, well, what's actually going on in this box a little bit in more detail, and what's going on in these boxes in a little bit more detail. On those, I would be more like the software architecture a little bit. And that's where I wouldn't be able to record